Okay, so what we are talking today is the graph of functions. Okay, so here, of course, we have a very strong tool like computers that we can draw the graph of functions, but this is not my point here. My point is to understand when we draw the graph of a function, what we do actually. So what is the meaning of the graph of a function? So let me we only, by the way, we only consider functions we take in only one real number and gives you out one real number. So forget about those general cases that functions in general can take in more inputs and can in principle give you more number of outputs. Only we consider the functions of this form. So we have f, it accepts one single input from us and gives back another output, one single output, and then the x belongs to the set of real numbers. Those are numbers, not generic functions, yes? And y is also a real number. So what we mean by the graph of such a function, yes? For example, when I write f of x equals to, let us make it very simple. So f of x equal to x. So what do I mean by the graph of the function? The graph of the function is the set of all points of this form. Let me just first define this for you. When I talk about the graph of a function, so the graph of a function y equals to f of x is the set of all points whose x coordinate I will call x, its y coordinate is f of x. I will explain these. The set of all points of this form where x belongs to the domain of your function. Okay, so this is a very more or less precise definition of the graph of a function. So when I talk about the graph of the function, first of all, you need to know that I mean a collection of points in the xy coordinate system. How should I specify those points? The x coordinates of those points are the elements coming from the domain of my function. What are the y coordinates of those points? They are calculated values of f at those x values. So for example, if 1 is in my domain, I choose 1, I calculate f of 1, 1 point would be f and 1 and f of 1. For example, if 2 is another point in my domain, I choose 2 for the x coordinate, calculate f of 2, it gives me a number, this gives me a point. So I will highlight these points on the coordinate system. After I have done this for all possible values of the domain, then I would say that that picture that I get is the graph of the function. Of course, this is not practical because usually how many numbers are in the domain, there are infinitely many. So now let me give you an example. Let me start with a very simple function. Let me just even start simpler than that. So let me consider the constant function f of x equal to 2. So can you tell me what is the domain of this function? Do you remember what the domain was? So what is the domain of this function? It means that the values for x that I can choose as an input for my function, is there any limitation? For example, if I ask you, by the way, what is f of 5, what is the answer?
2.
It's 2. If I ask you what is f of 3,
2.
it is 2. So it means that you see there is no limitation. I can put any number here because there is no operation with limitation here. The operations with limitation was the division and the powers, yes? So here there is nothing. So what do I mean? It means that the domain of this function is the set of all real numbers. In principle, I need to draw a diagram here. So let me set up a coordinate system. So this is the x coordinate and this is the y coordinate. For example, one of the numbers that I can choose from my domain, of course, is 1. I choose 1 from my domain. I put this 1 to my function. It gives me f of 1. But what is f of 1 is 2. Then I will have a point whose x coordinate is 1 and its y coordinate is 2. Then I will go here and try to find that point, yes? It would be better if I draw it more carefully. So let me draw this a little bit carefully so it passes exactly through the grids if possible. Yes, and then here. Yeah, that's good. So this is the y coordinate and this is the x coordinate. So this then means that I will go in my coordinate system and specify this point on the plane. So the x coordinate is 1, the y coordinate is 2, so this would be my point. That is it. I just highlight that point. So for example, let me change my color. This is one point that I put here. Yes, so this is one point of the what I call the graph of the function. Okay, this is done. Let me choose another point. For example, I have of course infinitely many, but let me choose another one. Let me say 2, for example. Now I calculate f of 2. What is the answer? Again, the answer is 2. I will take this one and put it as the x coordinate and the calculated one as the y coordinate. Yes, so again that one is 2. Then I will go and highlight this point in the coordinate system. This time the x coordinate is 2, the y coordinate is also 2. So this is the point that should be highlighted. So let me just do that. This is the point. Okay, let me just do another one. So here I will take, let us take 3. Then I calculate f of 3. The answer is again 2. Yes, so this will give me this point. X coordinate is 3. The y coordinate is the calculated value, which is 2. So this means that I need to highlight the point whose x coordinate is 3 and the y coordinate is 2. So this would be this point. Okay, so I will highlight that point as well. Okay, let me give you a negative number, for example. I am just doing integers because it is easier to draw them on the grid paper, but of course the domain is the set of all real numbers. From between 1 and 2, there are infinitely many numbers that I am just suppressing, I'm just ignoring, yes? In principle, I have to do it infinitely number of times. So this is why drawing the graph of a function is a technical and hard problem. We need to have some mathematical tools because by just this method, even though this is the crude definition of the graph of the function, but in principle, we will never able be to draw the graph of a single function because the domains are usually containing infinitely many points, and I cannot do this process for those infinitely many points. But I want you to understand the idea of the graph of the function, but how we can draw the graph of the function qualitatively with a good precision are the topics of the lessons in Math 3C and Math 4, okay? And so this is, you need to understand what is the meaning of the graph of the function. So for example, if I choose another number, let me this one take a minus 5, minus 1, 2, 3. So let me make it minus 4 here. I have it here. Then I calculate f of minus 4. The answer is again 2. So I will go, this is minus 1, minus 2, minus 3, minus 4. And the y coordinate that I calculated is this one. So I will highlight that point as well. Okay. But this graph is simple. I can, of course, can I say that the graph is just only these 4 dots? It's clear no, because I have just ignored a lot points, so that I need to highlight all of them. The point is that you need to highlight all those points. But the point is that the y coordinate, because of the nature of this function, is always equal to 2. Yes? So, for example, do you think that this point will also be highlighted at some point? The answer is yes. When I gave this small number to my function, then this point will be highlighted. This point will be highlighted. All these points at the end of the day, I hope that you have the intuition that all these points will be highlighted for different values of x that I choose from the domain. If I do everything at the end, what happens is a continuous line. I want you to understand, I am not connecting these points together. These points finally will form a continuum of points that is a straight line. This idea I want you to understand. Okay, so it means that if I do this process one by one, I will highlight all these points. But if this is finished at the end, I will get a continuum of points, which is a straight line. That straight line in this case is the graph, what I call the graph of my function. So this would be at the end, what I get is something like this. That is the graph of this function. Is that understandable? So what I want you to understand is that this is not correct that I get 2 points and then start connecting them. No, nothing should be connected. Okay? So you need to highlight these points individually on the coordinate system. It might happen so that these points are so many that at the end, when the process is finished, you get a continuum of points that you cannot see them as discrete points. So that would be the graph of the function. Is that clear, more or less? The idea, I want you to understand the idea.
Yes.
Okay. But for example, this becomes a little bit harder if I change this function. Let me choose another function. F of x equals to, is still simple, x. By the way, so let me change the name of the function. Here, people write it as y equals to f of x. Sometimes we write y equals to f of x, meaning that this graph is the graph of the function f. So let me see if I can bring it a little bit lower so that I have enough space here. Yes, good. Yeah, we can keep it here. Now let me change the name of the function so that I am not confused with f. So let me name this function this time g of x equals to x. Okay, again, if I ask you what is the domain of this function, you will see that the domain of this function is again the set of all real numbers, because there is no limit for the numbers that I can put in as x. All the numbers can be put in. Okay. But then again, because the domain is the set of real numbers, let me do this process. Let me take 1 from the domain again and calculate g1 this time. What happens? It becomes 1. Yes. So this means that I need to highlight this point 1 and 1, because I myself put 1 in. I calculated the y value. The y value is again 1. Okay, and then I need to go and highlight this point. So this point is 1 and 1. Oops, I made a mistake again here. So I didn't realize that I need to keep the grids exactly as before. So let me put it here. Yes. Okay, now this point 1 and 1. So the x coordinate is 1, the y coordinate is 1. So this means that this point should be highlighted. So let me change my color, for example, by blue. I put this point highlighted. And then, for example, I'm also allowed to put 0, yes? I'm also allowed to put 0. because 0 also belongs to my domain. Then I calculate g of 0. What is g of 0? It means that I need to calculate it. G of 0 is again 0. Hopefully you don't have any problem here understanding how I calculate the values of functions. So then it means that I put in 0, I got 0 back. That was a coincidence for this function. So this means that I need to go and highlight this point. This point turns out to be the origin, yes? So this point is also highlighted here.
I have a question.
Yes?
How do you know that g of, for example, x is equal to the y-axis? So g of 1 is equal to 1
This
and...
is always the case, yes? You
Uh-huh.
need to know, this I told you here, the graph of the function when we say the x value that we choose is the x coordinate on the x-axis.
And the other one is the...
And the other one
on
is
y-axis.
coming for the y-axis. This is
Okay.
that is the convention that we use all the time. The horizontal axis is called the x-axis. The vertical axis is called the y-axis. And then you remember when I say a point with coordinates a and b, a is the x coordinate and y is the b is the y coordinate. So when I write x and f of x, you need to know always that this first one is related to the x-axis and this second one is related to the y-axis. Okay, so this is another point that I will highlight. So for example, let me give you another point 2. I calculate g of 2, it becomes 2 again. So 2 and 2 is also highlighted. So you see that this 2 and 2 was highlighted even for that function. Now this is also highlighted for this new function. So let me make a small dot on it. So here, this is also highlighted. Again, I am not connecting these points unless I have a good reason for that. Okay, I will talk about that later. But you need to be patient, assuming, of course, there is no matter of patience. This is not possible to finish because there are infinitely many points. But if I consider more and more points, yes, if I highlight them, then at the end of the day, I will get a continuum of points, which is this straight line. Yes, so that would be the graph of this function g of x. So for example, let me draw it with a different color here. So that would be the graph of this function then. It should pass through these points, okay? So this becomes y equals to g of x. And for example, this point is the point of intersection between these two graphs. Yes, there is an intersection point here. But for example, this is why mathematicians actually start understanding the properties of different functions. For example, if you give me this or give me this, I immediately realize that these are straight lines. Okay, because I know the properties of these functions. So we will talk about that later in Math 2C. So as soon as I see this, I know that the graph of this function should be a straight line. As soon as I see this, I know the graph of the function is a straight line. But I have some of the other famous functions in my head. But in general, if you just pick up a random function and give it to me, I really don't know what the graph of that function is unless I start drawing the graph. Okay, but drawing the graph in general is not as an easy task. And then the reason becomes very clear. You see, this is hard because how should you be convinced that this, for example, I gave you these 3 points, okay, and if it doesn't matter how many points I give to you, I can, for example, draw this graph. This graph is also passing through all those points. But how should I know that the graph of the function is that straight line, not this curly one? Okay, so this is why I'm saying that it doesn't matter how many points you calculate. For example, assume that I calculate even more points. Yes, but still I cannot make sure because this function can go like this. Who knows? It can go up and then come back, goes like this, goes like that, passes through all the points. How should I know that the function is not behaving so strange? So this is why I want you to understand this point, that it doesn't matter how many points I provide, it is not a good tool in my hand to be able to guess, to have a qualitative graph of my function, because I can have infinitely many possible graphs passing through finitely many points. Okay, but which one is the real graph of the function cannot be decided just by putting numbers in and finding the answers and highlight the points. Unless someone tells me that how to find some particular points so that you understand the behavior of the function. Finding those particular points for a function is the subject of Math 3C and Math 4. But for the time being, you need to have a qualitative understanding of what is the meaning of the graph of a function. For example, if I want to give you another function, let me call this function h of x. This time, let me make it x squared. Okay, so now again, let me put x equal to 1 and I calculate h of 1. This is again coincidence, this becomes 1. So it means that I need to highlight the points 1 and 1. So this point, let me change this color now. Yes, this one. So this point is 1 and 1 here. Okay, and then let me calculate -1. Let me put -1 there. Then I calculate h of -1. What is h of -1? It means that I need to go to my function and calculate it. It is -1 to power 2, which is 1 again. So which point should be highlighted? A point that I give -1 to it, and I get 1 back. Yes, so this is this point. X is -1, y is 1. So this point should be highlighted. So I will take this point. Let me, for example, choose 0. If I choose 0, then I calculate h of 0. It is 0 to power 2 is again 0. So 0, 0 is also a point that should be highlighted. So the origin is also here. Let me give you one more point. For example, 2. I will give 2 here. So let me make it a little bit smaller. So I will give 2 and then I calculate h of 2. H of 2 is 2 to power 2, which is 4. So the point that should be highlighted is 2 and 4. Yes. So it means that I have this is 2, 1, 2, 3, and 4. So this point should also be highlighted here. So let me highlight that one. And then if I give -2, so you can see that what happens if I give you -2, there is no enough space. Let me just write the answer. If I put -2 here, the -2 in my function, -2 to power 2 is again +4. So this point should also be highlighted. So it means that -2 and 4. So this point should also be highlighted. So this means this. But then you see that you are in trouble. How should I connect the points? It is not trivial at all. Of course, you might have some knowledge about the graph of this function, but put yourself in that position that you really don't know anything about the graph of this function. How should you find the correct graph of this function? There are infinitely many possibilities. For example, one thing is just put them with the straight lines like this with sharp corners, yes? One way is this. Of course, this is not completely wrong. This is similar to the real graph, but the real graph does not have these sharp points. So it might be you say that, okay, I will draw the graph like this, and I will draw the graph like this. All of them are passing through this. Why the graph is not this one? This I will not be able to answer at this level, okay? But it turns out that if you draw the graph of this function, the graph of this function is a very smooth function of this form, no sharp points. I will draw it with GeoGebra that you can see that, okay? So this turns out to be the graph of the function y equals to h of x. So this is the meaning of the graph of the function. So let us just do these functions on GeoGebra. That's also very good to see that, okay? So if I go here, I will put here, do you remember what was the first function? The first function was f of x equal to 2, so I would write y equal to 2, the value for function. And then immediately GeoGebra draws the graph here. And that is exactly the horizontal line that I get it. But unfortunately, I don't know why. Let me change the color. In principle, it should change the color by itself. Let me make it blue. Okay. What was that? It was not blue in my, it was pink, more or less. Let me make it pink. Okay, so that was the graph of the function that we had there, yes? The next function, do you remember? It was f of x equals to, g of x equals to x. So here I would write y equals to x, yes? And then you see that I get this point, this line. So let me also change the color here. I think we did it red. So let me also make it red. Okay, so you see, even GeoGebra respects this. It names the first function f automatically. It named the second function g. I don't know what it will name because this is common in mathematics. Usually when you start with one function, you call it f. If you want to write another function in the same context, you choose g. Let us see what happens. Is it h or not for GeoGebra? So the third function is x to the power of 2. Yes, so I have a 2 here. And then let me change the color of this one. Yeah, you see, again, GeoGebra called it G. So let me choose that this is strong blue. Okay, so these are the graphs of the function. So you see that this convention is also working in GeoGebra. The first function f, the second function g, and the third function is h, which is y squared. So, and this is the real graph of that function. Okay, but I want you to understand what's happening. Something I want you to know. This is very important. Is that clear for everyone? Okay, so let me
Yes.
go back to this
Yes.
page. What is very important is this. You need to understand this. Assume that you have a coordinate system and then you have a graph there. So let me make it nicer. So first let me draw this. And then let me draw this. And then we can put, this is the x-axis and this is the y-axis. Assume that someone gives me the graph of some function, y equals to f of x. So f of x has a rule, yes? And that it turns out, for example, that the graph of this function is this one. And then someone goes and finds a point on the graph. Okay, and then he measures that this is A and this is B. This is a very important thing. So it means that this point has the coordinates, this point A, the x coordinate is A, the y coordinate is B. So first of all, by seeing this, you understand something. A, first of all, you understand this little a belongs to the domain of the function. Otherwise, it will not be a point on the graph. Immediately by seeing that this point lies on the graph of a function, you understand something about this a. That a is in the domain of my function. This is the first thing that you understand. The second thing that you understand is that if someone asks you, what is the number that you get out when you put a to the function? Can you answer this question now?
B.
Exactly. So if you understand the notion of highlight, it means that the reason that this point is on the graph, it means that at some point it has been highlighted. So it means that there was a point in the domain. When I chose that point and I calculated the value of that function at that point, I got B. This is why this point was highlighted in the first place, because I told you that the graph of a function is nothing except all the highlighted points at some point, yes? So when you see that this point lies on the graph, you need to understand that at some point, this point was highlighted. it means that there was a number in the domain, call it a, so that when I put this a into the formula for the function and I calculate it, it turns out to be b. This is why I see this point on the graph of the function. And if I ask you where b belongs to, can you answer this question? So do you remember this picture? Always in mind, I have two sets. When I talk about functions, one way of looking at the function is a correspondence between two sets. Yes? So this set is the domain. And then when
It's in the codomain.
It's in the codomain, but more restricted than that. This is domain,
Range.
you are right. This is the codomain. But there is something where it might be a smaller inside. And that is range, exactly. So that is also very important to know, that immediately you can conclude these things. So this typical picture, you should have it in mind when you talk about the functions and their graphs. As soon as you see the graph of a function, if you just pick any point there and read the coordinates of that point, you know that this x coordinate is definitely in the domain of my function. The y coordinate is definitely in the range of my function. And more importantly, if I put a as the input of my function and do the calculation, the number that I will get out is just this b. So this is a very simple but very constructive, I don't know, schematic that you need to have in your brain so that you
I have a
can work
question.
with functions. Yes, please.
And are we going to have questions that we're going to find the function or f and x while we have a graph?
No, but these kind of questions you will get. There are some exercises in the book that I have mentioned. So the questions related to understanding the graph of a function is very important for us. And there are some exercises in the book, so that I highlighted them in this recent message that I sent you on a SchoolSoft. Okay, so this is something that I want you to know. Let me just make it a little bit bigger now here. So let me just extend this a little bit. Okay, and then extend that one also a little bit. Okay, hopefully this is good enough that you can see. Okay, now my question is that, can you how can you find the domain in its full form? So assume that I want to have my domain. For example, they give you a graph like this, and then it will ask you find the domain and the range of this function. The function is not given to you. The rule of the function is not given. The graph of the function is given. And then you are supposed to find the domain and the range of that function. I told you the finding domain is possible usually. It takes time. The range is much harder, but not for the case that you have the graph of the function. By looking at the graph of the function and understanding the meaning of domain and range, in principle, you should tell me what is the range and what is the domain of this function. So how should I do that? For example, I want you to understand it yourself. So you agreed that this is a point in the domain. Can you tell me another point in the domain? Yes, I will take another point on the graph and I read the coordinate here. For example, x1. So x1 is also in my domain. I take another point, I read the x coordinate, say that is x2. x2 is also in my domain. But is there something between x1 and x2 that is in my domain? Yes, of course. If I put a point between these two, then I will get another point in my domain. So do you understand that if I ask you what is the whole domain, it goes from here, yes, up to here. So every point that lies here is my domain. Is that understandable? So in principle, I find the shadow, I don't know, I shed light from above and assuming that this is a rigid rod, I find the shadow of that rigid rod on the x-axis. That is my domain. The set of those numbers includes my domain. Is that understandable?
I have problem with the graph. Like I don't understand the graph itself, because if we say that whatever number for a we give, so it doesn't matter what number we give, we will get a b. And
No,
b,
no,
but it
it
says
matters.
f for a is
No,
equals to
no, you
b.
need to stop there. I didn't say that. For example, if I give a number here, I do not get a b. Yes?
Why?
So where is b? There is no point. So if that's what I'm trying to say. So here, this graph, if you see this graph is limited. So let me make it clear. So this is why even in the book you see that they have some filled small circles here. It means that if you see this graph in this way, this graph is not going to continue. It starts here, ends here. When I put a filled circle, it means that I am including this point, And there is also another way to put a hollow circle. It means that it comes up to that point, but it does not contain. Let me clean one of them and make it hollow, make it very clear. So assume that I give you a graph like this. If you see a graph like this, you need to interpret this graph in the way that it starts more or less immediately after this point, and it continues up to this point. If I ask you, if for example, if this is 5, if I ask you what is f of 5, you cannot answer this. This is not defined. That is exactly the point. I want you to understand that. Of course, most of the graphs will continue forever. Usually they have to put this arrow from here and here, showing you that this will probably continue in some way. So this at least tells you that this graph will continue. But of course, you will not know what will happen. Might be the graph goes here and then comes back up, and then I don't know, go horizontally, go back. So we don't know about this. But at least by putting arrows, people understand that this graph will continue forever. But if I have, yes.
In this question, what are you supposed to answer? Like, what is your answer?
I haven't asked my question because somebody asked the question.
Okay.
I'm just a little confused. So I don't know. Casual, could I answer your question?
Kind of, but I thought that f of a equals to b. That's like the general function, and that's why I was kind of confused. But then I looked at y equals a function of x, and then I realized that that's just the function that we gave for the point a, not the general function. I
Yeah,
see it
that's
right
not
now.
the general function is this function. These are different points on the graph of the function.
Yeah, I
Yes?
thought that it was the other one. That's why I became confused.
Oh,
But
okay.
thank you.
So, okay, so this, so let me just talk about this one because that's also important. So if I ask you what is the domain of this function, if you see this graph, then what you need to do is this. You need to find the shadow of this graph on the x-axis. So you will draw this point. So assume that, I don't know, for example, assume that this is 0.7, this point, assume that. And then I will go here and I will do this. So let me count 1, 2, 3, 4, 5, 6, 7. So assume that this point is 7.1. Okay? Now, if I ask you what is the domain of this function, this is possible to answer. Even if I don't know the rule of the function at all, I just want to answer this question using the graph of the function. So I would write this. I would write the domain of the function is the set. Do you remember? You need to respect these rules. You need to write the set of all x's where they are in R. We talked about why I put this symbol R here like this. And then x is between 0.7 and 7.1. But because this hollow circle, I understand that this point is not included. But because of this filled small circle, I realized that this point is included. So this means that I have to put equality here, but not here. So this means that by this equality, I am also including this point. By this strict inequality, I am excluding this point. And then I will end this, and this would be my domain. So this would be one question that you will get in the exam. There are some questions in the book like this. The graph of a function is given to you, and you're supposed to find the domain of that function. Is that clear?
Yeah, I guess so.
Okay, so, and then I can also ask the range of the function, even though the range in general is very hard to calculate analytically, but not when we have the graph of the function. Actually, this is the reason that the graph of the function is so helpful, because we can answer hard questions by just looking at the graph of the function. So this is why we spend a lot of time and energy on understanding the graph of different functions. Okay, if I want to ask you about the range, what I need to do? Do you have any idea before explaining this? Can you tell me what to do for this graph? What should I practically do in order to get the range of the graph? So you see, here it is here. The x coordinates are in the domain. The y coordinates are in the range. So when I talk about the range of this function, I am talking about all y coordinates of the points lying on the graph of this function. Yes? So for example,
Yes.
this point is a point on the graph. The y coordinate is here. This point is also here. So this point is also in the range. This point is another point on the graph. So this point
Can I
is
answer?
also. Yes?
And is it the lowest point of the graph and the highest point of the graph,
Exactly.
both of them,
Exactly.
between those?
Thank you very much. So if I don't know, might be this is the highest point. So what you are saying is that I need to find the highest point here, and I need to find the lowest point here. Do you agree every other point lies somewhere here? Yes or no? Yes?
Yes.
It doesn't matter. If I start moving on this curve and assume that I am just concentrating on the shadow of this moving particle on the y-axis, the shadow will be this. But of course, this shadow might be traversed more than once. Yes. For example, the point is here, close to here, I will be here. Then the moving particle goes down, so the particle starts from here, goes down, and then when the particle reaches here, it goes up. So you see, then it starts going up. So these points are traversed more than once. So then it goes up to some extreme point here, and then it starts coming back again. But anyway, what you said is exactly correct. So the range is this limited to these values. So for example, let me give some numbers here. For example, assume that this lowest value here is how much? For example, 1.5, say. I don't know exactly, but then the maximum point here is 1, 2, 3, 4, 4.5, for example. Then what should I write for the range? For the range, I should write all. It is common to write y for the range. If you write x, that's also correct, but let us respect the rules. So I would write y belonging to R. Y is between 1.5 and 4.5. So that's my understanding. I want you to see that you understand. Do you think that I include these points or exclude these points, the final points?
Include.
Includes, because this point, when I reach to this point, this is included. The only convention that I use, because of course it is clear that all these points are included, I don't need to emphasize on it more. But the endpoints can be included or excluded, and this is why I emphasize them by drawing these hollow circles and these filled circles. So this should be included. Thank you. So it means that your understanding is good. This is the level that I want you to
Can I ask a question?
Yes.
So if the lowest point of a function is the start and it's marked with a hollow circle, that means that
we have to exclude.
Yeah, exactly.
Exactly. For example, so if I draw something, let me just draw something like this. So if I have this situation, the graph starts from here with the filled circle and goes here hollow one. Yes. And then if this is 1, this is 2, this is, for example, 4, then the domain is between 1 and 4. Sorry, the other way around. Oops, I will lose all of them. So assume that I have this situation, this is filled and it goes up to here, and this is a hollow one, and assume that this is 1 and this is 4. So if I ask you what is the domain, you would say the domain is X, including 1, excluding 4. And if I ask you what is the range, you go here. For example, assume that this is 1, this is, for example, 5. So the range would be Y between 1 and 5, but 1 is included, 5 is excluded. Yes, so it depends to the maximum value and the minimum values. If the maximum values and minimum values occur at the end points, then you need to be careful about including them or excluding them. But if the maximum and the minimum are happening at somewhere in between, of course they are included because they are part of the graph of the function. Is that clear?
Okay, then I understood correctly. Yes, thank you.
Yes, thank you. So for example, if I give you this this one, by the way, let me exclude these two first. Yes, by looking at this graph, you see, when there is no end points, this graph will continue forever. Assume that I give you the graph of this function and I tell you that this graph will continue forever from both sides. Then just by looking at the graph of this function, what do you say about the domain of this function?
Perhaps all real numbers.
Exactly. And what about the range of this function?
It's the same.
Wouldn't it only be 2?
Exactly. That is only one number. So that is, so if I, about that function here, so let me go back here. So if I ask you what is the domain of this function, by looking at the graph, assume that you don't know the rule. Here we know the rule, of course, because I started from the rule of the function. Assume that you don't know the rule, but you only see the graph of the function. And I am telling you that this graph continues forever. Just by looking at the graph, you immediately realize that the domain is the set of all real numbers. Okay, but now if I ask you what is the range is the shadow of this graph on the y-axis. So if the particle starts moving this around, the shadow is always one single point on the y-axis, and that is that point, which is one single point. So the range of this function is the set consisting of one single number, and that is 2. Is that understandable?
Yes.
I have a question. So is there any situation where the domain is the same as the range? Like, I mean, not that they are the same, but like they're equal to the same.
We have it here. So let me clean this one, and when we go here, this is the function as an example of your function. Assume that I give you the graph here, and I ask you, and I tell you that this continues forever from both sides. Then I ask you, what is the domain of this function? Can you tell me?
All real numbers.
All real numbers, because the shadow of this on the real axis, if the particle starts moving here, the shadow would be all the points. Yes. So this would be the real number. If I have the same question for the range, what do you answer?
All real numbers.
All real numbers. So that is one question that actually you asked. So the range and the domain of this function are both equal to the set of all real numbers R. So this can't be possible. Let me clean this one and highlight this one. Assume that I tell you that this continues forever. This is a little bit tricky. Okay. If I ask you what is the domain of this function, what is your guess?
All real numbers.
all real numbers. Might be it is very hard to believe in that, because you are saying that, okay, this graph, when I go to the right, it comes up to nearly this point. The
Can I
reason is that,
modulate
yes,
my
but
answer?
it actually, let me just tell you. So you see, this number is now 4. So if I go in and in, so this number is 10. So it means that still I have some graphs. But if I zoom in and zoom in and zoom in, still I have graphs, you know, this is nearly 100. Of course, this function goes to the right very slowly, but there is no reason to believe that this function will not go to any number on the right. It goes very slowly. The reason this function doesn't actually goes very slowly to the right, it goes with very high speed to the up, you know, it increases very much. So this is why you feel that this doesn't go to the right that much, but there is nothing that you can say about you don't believe that. Okay, but now let us ask you about the range of this function. How should I do this? Yeah, I need to come back. So what is the range of this function? Let me, what happened, I don't know. Oops.
You zoomed in too much, I think.
Yeah, you should zoom out and
No,
then
this is,
go down.
yeah, I need to zoom out, but it will not work that easily. But I just look here. Let me make it one by one, if it's possible. Yes, that's the starting point. Now I ask you, can you tell me what is the range of this function? What is your intuition actually about the range of this function?
All real numbers that are higher or equal to 0.
Exactly. So if you see the shadow of this graph on the y-axis, there will be no shadows below the x-axis because there is no track of the function at all. But you, first of all, you agreed that this point is on the graph. So this means 0 is included in the range. But every point on this one is just a shadow of 1 point at least. Of course, each point here is the shadow of 2 points, one on the left, one on the right, but only 1 point is also enough for me. So that is also something that you need to know, okay? Okay, now let me give you a little bit more analytic problem here. So I would say that, example, determine k such that the graph of the function say f of x equals to x squared plus kx plus 5 passes through the point two and -3. So this is something that you need to know. That is analytic question about the graph of the function. So a function is given to you here, analytic form is given, and you see that there is one missing parameter in the formula for the function k. You are supposed to determine k such that when you draw the graph of this function, you see that the graph of this function passes through this point. Okay, before giving you any hints, can you tell me how should I solve this problem? You need to understand, you need to have a good understanding of this picture.
Could you like put the numbers you get in the form function?
Yes. So for which, so yes, exactly. So you are saying that, you see, this function, this question is asking you, this function, the graph of this function is supposed to pass through this point. So this means that this point lies on the graph. So it means that at some point, this point should be highlighted. So
Yeah.
it means that when I put x equal to this 2, the answer should be -3. In that case, this will be highlighted on the graph. So exactly, what we solve is this. I would say that 2 minus 3 is a point on the graph of the function y equals to f of x. From this sentence, this gives me this, that if I replace x with 2, the answer is supposed to be -3. Yes, so this gives me this, that 2 to power 2 plus k times 2 plus 5 is equal to -3. So let me stop at this point. Everyone understands what I have written here in green?
No.
Okay,
Yes.
so this sentence is given in the problem. Do you agree with me?
Yes.
Because when you say that this graph passes through this point, it means that this point lies on the graph. Yes?
Yeah.
From this statement, what I understand, let me go back here. You see, if A and B is on the graph, you can see that I have written it here. F of A is equal to B. Yes?
Yeah. Yeah.
Is that understandable? So I have just done the same thing. F of x is this one. I know that 2 minus 3 is on the graph. So it means that this is playing the role of A, this is playing the role of B. So it means that f of A should be equal to B. But A is 2. So f of 2 is equal to -3. Yes?
Yeah.
Okay, so let me, if you want, I can write this before that. F of 2 should be -3. So this implies that. So I would say that from this sentence, which is mentioned in the problem itself, by my knowledge, I conclude this one. But this, in terms of this problem, can be translated into this form. Is that understandable now?
Yeah.
Okay, and then you see that one thing is missing. Let me simplify that. Instead of 2 to power 2, I put 4. Instead of k times 2, I write 2 times k. And then I have 5. And then I have -3. Then I simplify that. 4 and 5 becomes 9. And then I have 2k. And then I will have -3. So what happens? It means that 2k is -3 minus 9. So this means that 2k is -6. This means that k is -3. So that is the answer that you need to provide for. So some problems are related to the graphs. You see, there is the notion of the graph in this question, but you really don't need to draw any graph. You need to understand what's the meaning of the graph and try to use your understanding to find what is wanted in the problem. Is that clear?
Wait, Babak, -3 minus 9 isn't -6.
Thank you very much. Thank you very much.
You're welcome.
So that I was answering myself in my head. The answer is -6. This is -12. Yes, thank you very much. So the answer is what? -6. Okay, but let me check this with GeoGebra. Yes, so it means that in GeoGebra, I will try to find this point. And now that I understand that k should be -6, I put -6 here. So what I will get the function x squared minus 6x plus 5. And then I will draw the graph of this function. Let's see that this will happen or not, okay? So here I go to GeoGebra. Let me get rid of this. Then I want to have the point with coordinates 2 and -3. So x coordinate 2, y coordinate -3 is here. So let me highlight that point. 2 and -3. So this is my point. Yes? And you see that here it is mentioned that A has coordinates 2 and -3. So do you remember what the function was? the function is this function, x squared plus kx plus 5. But now I know that k is minus 6. So let me put minus 6 here. It becomes x squared minus 6x plus 5. Yes, x squared minus 6x plus 5. I will go here. I would write y equals to x squared, yes, and then minus 6x. You see, it's not passing, but in principle, as soon as I put 5 here, it should work. And then we see that that's correct. You see, I drew the graph of this function, and then I realized that the graph of this function is this one, and it really passes through the point that I wanted, yes? So this is the analytic way of solving the problem, and GeoGebra also confirms that in practice. Any questions here? No?
No.
Okay, let me give you another example of this analytic type. Example. Determine K and M such that the graph of the function f of x equals to kx plus m passes through the points, for example, let me call it A, minus 2 and 1, and B, 1 and 3. Okay, so let me take this problem with me to the next page. There are not enough space here. So that is more or less the same problem, but here we have two unknowns, K and M. And this is why they have provided me with two pieces of information. I know 2 points on the graph instead of just knowing one of them. Okay, so how should I write that? I want you to fully understand these sentences that I am writing. I would say that A is on the graph. So this means that the coordinates of the point satisfies the graph formula. So it means that if I put minus 2 for x, the answer is equal to 1. I want to make sure that everybody understands what I have written here. Is that clear for everyone? This is my point.
Wait, the f minus 2 equal 1. How did you get that?
That's the problem. I just so it means that this point lies on the graph. It means that if I put minus 2 instead of x, the y would be 1. That is the meaning, yes? So I need to go back because this is very important. I don't know.
Okay.
Some people find it hard to understand, but that's not hard, is it? If you don't understand, let me repeat this again. If you have a point on the graph, the coordinates of the point will satisfy the equation of the graph. What does it mean? It means that if you take x and replace it with the x coordinate, you get f of a. If you take y out and replace it by b, this would be the answer. So f acting on a will give you b. By looking at this, that this point lies on the graph, you need to understand that f acting on x will give you the y coordinates. Is that clear now?
Yeah.
Okay. So let us go here again. Let me write another sentence, then I will translate it to B is on the graph. So everyone tell me, what should I write? What can I conclude immediately in front of it? By looking at the coordinates of this.
F of 1 is 3.
Yeah.
F of 1 is 3. Okay? So this is what you need to learn from this lesson today. But continuation of this is the previous lesson. If I ask you, how do you calculate f of -2? If I give you the formula for the function, this is the previous lesson. You would say that I go to my function, I will take the input x out and substitute it with this -2, which is given. So this means that k times -2 plus m is equal to 1. Let me explain. This 1 and equality is just this one. I copied and pasted. But instead of this expression, I wrote this. Is that understandable? Okay.
Yeah.
Okay, and then what should I write? I would write -2k plus m is equal to 1. This is one thing that I have. And then I will translate this one similarly, yes? How should I write? How should I translate this? Equality 3 is copied and pasted. Equality 3, equality 3. Forget about this for the time being. Concentrate here. If I ask you what is f of 1, you should be able to answer that. You go to your function, you want to calculate f of 1, it means that you take x away and replace it with this given value. So then it becomes k times 1 plus m. Okay? But nobody writes k times 1. People write just simply k, and then I have m equals to 3. And that is another equation that I have. Yes? But there are two unknowns, two equations. So this is simple. Hopefully you know how to solve it. So I have -2k plus m equals to 1. And I have k plus m equals to 3. How should I find the k and m? I need to solve a system. I don't know how do you want to solve the system, how you have learned it in growing school. And so one we can do is to just multiply this by a negative sign, yes? Let me multiply the above one by -1. So then what happens? The above one becomes 2k positive. Positive m becomes negative m. On the right-hand side, it becomes -1. The second one, I just copy and paste. And then I add them side by side. When I add them, this positive m and this negative m are canceled. This 2k and this k are added. It becomes 3k, yes? So this becomes 3k. On the right-hand side, I have -1 and 3 added. It becomes positive 2. And then I am looking for k, so I divide by 3. It becomes 2/3, yes? So this is the answer that I will get for k. Okay, and then when I found k, I put them in one of these equations, which is simpler. I think the second one is simpler. So I replace this k here, and then I will find my m that I don't know, yes? So this becomes 2/3 plus m equals to 3. And usually I don't like fractions, so I get rid of them as immediately as possible. I just multiply by 3 everything, so it becomes 2. The next one becomes 3m. The right-hand side becomes 9. And then what happens? 3m becomes 7. And then m is also found to be 7/3. So here, because the answer is what is wanted, determine k and m. So this is the answer actually. But if I ask you what is the function for k, you can replace it here. It gives you, so the function, this I write it with a different color. This is not part of the solution. So the function is f of x equals to 2/3x plus 7/3. Okay, and I want to check this with GeoGebra. Okay, I don't know if you're taking notes. The functions are -2. The points, I cannot memorize them right now. So let me write them on a piece of paper. And then I go to GeoGebra, 2/3 x plus 7/3. But you need to trust me on that. So here we have a point A and B. I want to highlight them on GeoGebra and ask the GeoGebra to draw the graph of this function and finally confirm that the graph of this function that we found indeed passes through these 2 points. Okay, so let us check that. So let me get rid of all these. Okay. Now there are 2 points. One of them is -2 and 1. So -2 and 1 is this point. So I will go here. This is one of my points. Yes. This is supposed to be, by the way, A. But GeoGebra do it automatically. So let us show label. We don't need the label. This is one of those points. And the other point is 1 and 3. So 1 and 3 is this point. So this is also point. Let me get rid of the label. Okay, these 2 points. And now I go and type the function that I got. If you remember, the function that I got is y equals to 2 over 3 and then x, and then we have plus 7 over 3. Yes, we are confirmed. Yes, so you immediately see that I have done it correctly. So this function exactly passes through the points as I calculated. Okay, so this is also a confirmation coming from GeoGebra. Is there any questions?
Yeah, I have a question.
Yes, please.
When you try to get the m.
Yes. Let me go to the page. Okay. Let me go to, yes.
Could you like do 3 minus 2/3, and then you get the m?
Yes, yes, exactly. Yes, yes.
Okay.
Might be in this case, this is simpler. Yes.
Thank you.
But usually when I do something for teaching, it's better always to follow that rule, because otherwise people say that why Bobak sometimes do this, sometimes do the other thing. Yes. But that's up to you. If you have a better understanding, you can do it your own way. Okay. Any questions here?
Yeah, just a question. This will not actually be on the test, will it?
No. I told you that read just because this time is very limited.
Yeah.
And I don't want to give you a lot of stress, okay? Yeah. But this is not something above your knowledge. This is something that you can immediately understand.
Yeah, it makes sense. Just that I need to know.
Yeah, exactly. Any questions here? One thing, even though it is not in your lesson, but it's very important to understand that. So how graphs can help us to solve equations? For example, I just do it quickly because this is not part of your lesson. We will study it later, but this is still possible to understand at this point. So for example, I want to solve this equation, x to the 3 plus x equals to 3x squared minus 1. Okay? This is a polynomial equation of degree 3. And this is in principle hard to solve. Even if the degree goes higher, I don't know how to solve it. So you need to use numerical methods to be able to find the answers. So what I'm trying to say is that don't think that this is a simple question in mathematics, solve a polynomial equation and find x. It's usually not that easy to do that. But assume that you don't know the analytic way, which you don't, but you have the GeoGebra available. Of course, GeoGebra, I think, has this instruction of solving equations. We can check it later. But assume that you have the graphing tool and then you want to find the roots, or at least you want to know how many roots are there, how many solutions are there for this equation. Do you have any idea what to do? Assume that you have GeoGebra, can draw any graph for you, and then using that tool, you want to have an idea about the answers of this question, of this equation.
Well, if we get everything on the same side and then we can just put y on the empty side, maybe that would work.
Okay, but that will work, yes, but you need to have a good interpretation. So let me just do what you said. So let me move everything to one side. So it becomes x to the 3 plus x minus 3x squared minus y equal to 0. Then I will get a function y here. So I have two functions, f of x equals to...
Isn't it plus 1?
Yes, plus 1, thank you.
Yeah.
3x minus 3x squared plus 1. And the second function is, by the way, g of x, let me call it, it is equal to 0. So the left-hand side function, I call this one. The right-hand side function is this one. Yes? But every one of you hopefully immediately know the graph of this function, even though the graph of this function is complicated a little bit for you. But the graph of this function should be very simple for you. Can you tell me what is the graph of this function?
A straight line.
A straight line passing where?
And
In
origo.
which way? Origo and then horizontal. Yes?
Yeah.
So this is exactly the x-axis. It is supposed, so do you everybody understand that? Because for example, if I ask you what is g of 1, you get 0. When I say what is g of 2, you get 0. G of square root of 3, you get 0. So it means that if I want to highlight the points, 1 point is 1, 0. This is 1 point. Another point is 2 and 0. Another point is a square root of 3 and 0. So all these points will be highlighted. And at the end of the day, you get the x-axis. So this I want you to know. If I ask you what is the graph of this function, g of x equal to 0, then that is the x-axis. If I ask you what is the graph of g of x equal to 1, that's a horizontal line passing through 1. If I ask you what is the graph of the constant function 3, it is a horizontal line passing through 3, yes? So these are easy to understand. Now you know the graph of all these functions. All of them are horizontal lines. Depending to this value, you need to find that point and draw the horizontal line. Okay. Now what you are saying is that I go and draw the graph of this function. The graph of this function is already clear. That is the x-axis. But then what? How should I find the answers to my original problem using the way that you described? Okay. Let me try to describe it for you. So assume that you have a system of you have a coordinate system, and someone tells me that the graph of a given function is something like this. It goes up and down, then here, and then there, and goes up. For example, like this. This is y equals to f of x. And then they will give me these points. For example, let me call this one 2, for example, 2.5. This point is 2.5. I don't know, 1, 2, 3, 4, 5. This point is 5, and continue. Let me ask you one thing. What do you think would be f of 2.5?
0?
0. Yes, exactly. This is 0 because the height of this point. If I ask you what are the coordinates, of course, the x coordinate is 2.5, but for reading the y coordinate, you don't have any trouble. It's already on the x-axis. So what is the y coordinate? It is 2.5 and 0. And then because this point, do you remember this picture? It's a very important picture. When a point is on the graph of a function, it means that if you apply f on the x coordinate, it will give you the y coordinate. Now, in this picture, you see that this point lies on the graph. So and then I can read the coordinates, 2.5 and 0. So it means that if I apply my function on the x coordinate, it will give me the y coordinate. So this is why you were able to immediately answer this one equals to 0. Now immediately, can you tell me what is f of 5 in this picture?
0.
0.
So again, if I have this one, for example, minus 3, what is f of minus 3 in this picture?
0.
0. So if I ask you how you solve this equation, how you solve this equation, 0, how you answer this equation, this question using the graph, how do you answer this? So for example, in this picture, let me give you numbers here. So assume that this is 7, this is 8. That's it, for example. Now I am asking you the values for x so that if acting on them gives you 0. What's the answer? What are those values of x according to the picture that you see?
3,
-3.
2.5. Oh, minus
Yes,
3,
all
2.5,
these
5, 7,
numbers.
8.
Exactly. So these numbers, so immediately you can conclude that x is -3 or 2.5 or 5 or 7 or 8. These are the numbers that I want to find by looking at this picture. So it is very important, if you have a function on the left equal to 0, and then you want to find those values, you need to go and read the x coordinates of the intersection between the intersection points of the graph and the x-axis. So this is why we can use GeoGebra to solve this problem now. I can draw the graph of this function, which GeoGebra is very good at it. And then I will go and read the intersection points, the x coordinates of the intersection points. Those are the answers to this equation. I want you to understand the concept. Is that understandable? Because I can teach you, okay, do this, this will give you the answers, but I don't want you to memorize them. I want you to understand them by this example. So if I have a function equals to 0, and I want to solve the equation, which is a completely different problem, I can use the idea of the graph of the function to answer this question. But you need to know how, and you need to know why this method will work. How is easy. How is go and draw the graph of the function and then check the intersection points and read the x coordinates. These are your numbers that you are looking for. But I want you to have a deeper understanding by having these ideas that I just told you. I want you to understand that this method indeed works. Questions? Okay, let me just do this one. Let me write it here so that I don't make a mistake. The function is x cubed plus x minus 3x squared plus 1. Let us see this in practice. We go to GeoGebra. Let me get rid of all these. And then what I put as my function. So yes, I wrote it on a piece of paper. So x to the 3 plus x minus 3x to the 2 plus 1. Oops, it's not working. Yeah. Oh, 1 should go down, plus 1. Oh, I forgot to write y, so this is why it's not sensitive. Oh, it's this one. Yeah, y equals to this. Now you see the graph of this function. Now I ask you, what are the solutions to this equation? What are the solutions? I need to go and find the intersection points between these two curves, this curve and the x-axis. At least you can immediately tell me how many roots are there. How many? How many
with roots in this question?
Pardon?
What do you mean with roots
Root
in
means
this
solution.
question?
Solution of an
3.
equation is called the root.
3.
So there are 3 because I see one intersection, second one, and the third one. Okay? But if I ask you what is the number, you need to find these intersection points and read the x coordinate. One of them is very transparent. What is that one?
1.
1.
1. Definitely 1 is an answer. By the way, you can check it in your head. If you put 1 instead of x, let us see what happens. 1 to the 3 is 1, plus 1 is 2, minus 3 is minus 1, plus 1 is 0. So yes, 1 is a really answer. But this one is not easy to read. We know that it is somewhere between 0 and minus 1. This one is somewhere between 2 and 3. there is an option in GeoGebra. You go here, you see there is something called intersect. You click on that, it will be on this mode, and then you go and press on this one. This becomes highlighted, and then this one that you want to find the intersection point. So it gives you 3 points of intersection. You don't need to do it by hand. And now you go and study these numbers, yes? So one route, you see the x-coordinate is 1, as we guessed, and that is E point. And now if I ask you what is this one, you see it's negative 0.4142 up to 4 decimal places. And then if what is the another answer, another answer is 2.4142 up to 4 decimal places. So that is a very extreme tool in our hand, so that we can answer the questions that still we don't know how to solve them analytically. Some of them you will learn when you go to higher mathematics. Some of them is not possible. We need to develop some methods so that we can find those numbers to any degree of precision, but we will not able to find the final answer because some of the equations have, for example, irrational roots. And it doesn't matter how many decimal places we go in, we will never able to finalize that number. Okay, we can also find some other methods to get exact values, but that is another story. I want you to understand the concept of the graph of the function is extremely important to answer different kinds of questions. Okay, just one point as a curiosity, we can also do this problem in a different way, yes? Let me ask you this question. This is also very important to understand. So if I have a graph, if I have 2 graphs, I want to see how you answer this question now. I always forget to do this first. Okay. Now assume that I have a graph of one function, y equals to f of x. Then I will have the graph of another function, say, for example, this function. Oh, let me not make it so complicated. So let me have this function, y equals to g of x. Then this intersection point and this intersection point, I have it. Okay, let me ask you this question. I want to see how many of you can answer it. Yeah, so here, let me call this point A.
But you're still showing the GeoGebra.
Oh, sorry,
Yeah.
thank you. Okay, just, yeah. So here I have 2 graphs. Let me repeat. This graph is the graph of this function. And I have another function. The graph of this one is the green one. And now I am telling that assume that I give you this A and I give you this. Let me write them with x1 and x2. It's easier, might be you're not confused. x1, x1, and x2. I want to ask you something here. What do you think is the relation between these numbers, f of x1 and g of x1? Similarly, what is the relation between f of x2 and g of x2 by looking at the graph of this function?
The only 2 intersection points between these 2 graphs, maybe?
No, yes, there are 2 intersection points. What is the relation between this and that?
Do you mean that they are the range or something?
No, what is the relation? I cannot give you more.
Do you mean that they share x1 as the thing they work upon?
No, so what I'm saying is that what is the meaning of f of x1? It means that you have a machine, you put input x1 to your machine f, you get an output. Yes? You have another machine g, but you provided it with the same input and you get an output. What is the relation between these 2 outputs if this is the graph of these 2 functions?
It's the
They are
same
equal?
output.
Yes, they are the same output. That's the answer. And this is also the same. Why is that the case? Because at this point, let me call it x1, and another point, let me call it y1. You see that this point lies on the graph of this x1 and y1 is on the graph of f of x. So this implies that f acting on x1 gives you y1. But on the other hand, x1 and y1 is on the graph of g. Okay, tell me what will happen. This information, you need to be able to translate this information, which is an English sentence, into a very summarized and compact form. Can you tell me what should I write in front here?
F of x1 is equal to e1.
Not f, because this is g.
Okay, g of x1.
Exactly. G of x1 is equal to y1, yes? But you see that this one is equal to y1. This one is also equal to y1. So then it means that these two has to be the same. So f of x1 is equal to f of x2. Is that understandable?
Yes.
So if you have the intersection points with for the graph of two functions, you immediately realize because this point lies on the first graph, I can write this. The same point lies on the second graph as well, so I can also write this. But because y1 is the same quantity, and this one is equal to y1, this one is also equal to y1, and y1 is the same quantity, so it means that these two has to be the same. So I can immediately conclude this one. Yes? So what
How
now
could you
what
conclude, Babak?
yes?
How could you conclude that fx1 is fx2 if fx1 and gx1 are the same?
No, you are right. You are right. Yeah, sorry for that. I have to write g of x1. Thank you very much.
You're welcome.
Yeah, but you understand at least. This shows that you understand what's going on. Now, let me solve this problem that we had before using another method. Can you tell me what is another method to solve this? Instead of moving everything to the left and compare it with 0, which I prefer this one that Rocco mentioned, but I want to play with these concepts so that you can understand these things deeper. If I don't want to move this to the left, is there still another way to use GeoGebra to get to that solution?
Didn't you say earlier GeoGebra had an algebra solving thing?
No, forget about that. Just by graphs. In the method that you mentioned, I moved everything to the left. I just drew the graph of one function and find the intersection points with the x-axis. That is the best option, I would say. But there is another way to do this. I draw the graph of two functions here, yes? I draw the graph of this function, let me call it f of x. I draw the graph of this function, let me call it g of x, and then look at the intersection points between these two graphs. Okay, so what I do, I will draw this with GeoGebra now, two graphs, and then let us check what is going to happen. And that would be the last example today. So let me just get rid of these points, but the points are on GeoGebra that you can see them. And let me just get rid of this function as well. And then I will try to draw two new functions. One of them is the left-hand side function, y equals to x to the 3. Is it drawing or not? Yeah, here, x to the 3, and then I will have plus x. This is one of the graphs, and then I go to the next graph, y equals to 3x to the 2 minus 1. Okay, so you see, if I can zoom in a little bit, this is the graph of two functions. So by the way, how many intersection points do you expect? Tell me. From the previous calculation. These are actually very deep questions, by the way.
Perhaps 2.
2.
No, but you have already solved this problem. How many answers were there? Do you remember?
3.
Weren't there 3?
Three?
It was 3 solutions. So it should be still 3 solutions, but unfortunately we see 2 intersection points. Is that right?
The last intersection point is on the right side if you zoom out.
Yeah,
Yes.
exactly. So there should be another one, which we cannot see actually. So let me go to intersection points. This one, yeah, these are, so I don't know what are those points. So let me get rid of all these. And then let me do it once more. I go to this intersection points and then I click on the black one and the red one and I don't get anything. It doesn't work sometimes. I don't know. This one is highlighted. I don't know why it doesn't work.
I think it's because you already did it and it gave you G and H and then you unclick them.
So it should do this. Might be, yes. So, okay, so that is not working now. But this point is M. I don't know. This is not also the good one. Yes, that's a good one, actually. You see, the x coordinate of this point, this is totally different point. But if you go here, the x coordinate is exactly 1. And 1 was one of the points that we got from the previous solution. This is why Rocco's method is better. You see, if I want to solve this problem in this way, then I will have a problem because I want to compare 2 curves and to find the intersection points. And these intersection points, one of them is actually very high. I cannot see it here. But when I draw it with the x-axis, I can do it simpler. So this is why the Rocco's method that you move everything to the left is preferable here. And let me just do this one if I can do it with my eyes here. Click here. And then you see this is n. Do you see this number? This number is exactly the number that we got before. This number is here. Yes? Minus 0.4142. The y coordinate was 0 because that was the x-axis. But now the y coordinate is a different number, but we don't care about that. We only care about the x coordinate. And that x coordinate is exactly the way that we have it here. These things that I am talking to you are conceptually very important to understand why these methods are working. Okay? So if you don't understand that one, we can just talk about this later in Math 2C. But this one, of course, I will never do this problem in this way myself. I will prefer to move everything to the left and compare that with the x-axis, because that is much easier. But let me see if I can find that point as well. This is very hard to detect that. No, it's not that point. Is that point? It seems that point. Yeah, I accidentally clicked there. So this GeoGebra
has the same y value.
The same y value, yes, because all
look
of them.
Look at O.
But let us go here to the previous one. Yes, here. F. That was the solution from the previous method. We find 2.4142 for the x coordinate. But now if I go to O, the y coordinate is totally different, but who cares? What we care is the x coordinate. And the x coordinate is exactly the same number. Okay? So that's also possible. I brought this up because understanding and expecting this will happen has a deep connection to your understanding about the graph of functions. Yes? So that is actually the last lesson that we had for this. Tomorrow I will not teach anything at all, so you can go and practice on the problems that I have mentioned already, and then we will have the test on Wednesday and we will finalize the grades. Okay, so let me stop this video now from being recorded anymore. Thank you.